All right, looks like everybody's back. Rich, by the way, were you able to do the download?
So I paused it during this session because again my internet has been having some issues. But I'm gonna finish it up after after we finish this training session today, and I'll download it overnight tonight.
Okay, sounds good. I did try to compress it just to see, but it took about a gig out of it, which is actually it's not bad.
Oh yeah,
I know with
that'd be great.
MP4, right, it's a lot less. But since you already started it, might as well just continue it.
Yeah.
But in the future, yeah, I'll make sure I compress it. So.
Okay.
All right, so let's take a look at classification hierarchy. So we already talked about that yesterday. I showed you some examples, and we'll see some more. So the idea is, again, has to do with these generalization relationships, right? Like inheritance. So you're building hierarchies when blocks have similarities, right? They're like 80% the same, or they have commonality, in other words, right? That you build them out as a hierarchy. Again, the idea is that just like any object-oriented concept, that you try to define a given property or given behavior one time, one place, right? You try to clone as little as possible. And so if you can have a hierarchy then where you push up, right, you inherit, if you will, things from other existing blocks, or same concept you can use also with interface blocks, right, to specialize them with value types. I showed you that, where I had real I think I had this, see if that hyperlink works. Right here, right, so you have a real, and then everything else, right, is basically a specialization of the type real. Let's see, let's view, okay, and same thing with signals, we'll see that in a little bit. So you could do it with different things, right, not just with blocks. And so the whole idea is, right, you have common features, structural, behavioral, you push them up in the hierarchy, right, and then the lower ones automatically inherit them. And in the specialized classifiers, specialized blocks, or whatever it would be, then you just specify the things that are just unique, right, to that particular element, or that can also get inherited right downstream by other blocks, for example. So if we look at, here's an example from also from a surveillance system, where you have the camera, and you have like 4 specializations. There's like a very formal way in UML which you can mark that it's not really that important. But here we're basically taking the concept of a camera. Of course, I don't have all the properties on here, right, just to reduce the size of the diagram. But I'm basically splitting it. I'm specializing it in 2 different perspectives, if you will. One is by connection type. So okay, I have wired camera systems, right? And I have wireless, and then also from where they're actually being used, like the location, right? To say, well, I have them internal, right, or I have them external. Obviously, if you have things like external camera systems, they need a housing, they need to be protected from the weather, something like that. So there's there's other things that come into play, right, between these two. And so there's two different hierarchies, right? So in independent hierarchies, right? Wired and versus wireless, internal versus external. And so now you could start going, like for example, a wide camera, right, would have like an Ethernet card, a power supply, right? Wireless would have a battery and a Wi-Fi card, for example. But now you can also start from an inheritance perspective. You could do like multi inheritance, right? Multiple inheritance, really, where you say you have a wired internal. So it's wired internal is a specialization of the wired camera, so it has all the properties and behavior of a wired camera, but it also inherits from the things that an internal camera would have, right? Versus if I have a wired external camera, that would be a combination of this one with external camera, which would have a housing, right, external housing, things like that. So you can build up pretty intelligent hierarchies like that. And again, the whole idea is like, ideally, right, everything should be defined. Any possible property on the whole array of camera systems should be defined in one place, one time, ideally. Right? I'm not saying sometimes you do have to clone or something would show up in two places. But ideally, if you can structure it right, you're trying to minimize that, right? Just like in code. So that's the general idea. And if we look at another example here for a signal, right? Again, I could have like a generic or basically a basic signal, which is just has is just a system message, right, that goes across. And let's say that every signal always has some kind of unique identifier for it. And then I can specialize that into like alert messages, right? Just system on, system off type, where I don't need any additional property. It's just literally like a flag, right? A bit, it's either on or off. And then I can have another special kind, which is a message. And if it's flagged as a status message, then I always have some kind of date timestamp on it, so that I can track, right, the over time what happened, etc. So again, specializations, right, of these different kinds, and that, so some of these hierarchies can be fairly complex, right? But again, from an inheritance perspective, if I look at like status report, right, here it shows one property, but really it has three properties, right? Because it inherits the date and time to this path here. And of course, each one of those inherits, right, the system ID property. So this particular signal would not have one property, you would have three of them, right? Let's see. So element authority attributes. Right. So we'll take a look at signals a little bit later. I'll show you how to build them because they're done with attributes. But the only place in SysML where we use attributes, which was like a UML concept, because signals come directly from UML, that's about the only place that you should use attributes to define, right, the actual content, the payload, if you will, of these signals. Now, let's take a look at the behavior. So we pretty much covered the structural side. Now we're going to look at the behavioral side of the blocks, right? And so from a behavior perspective, and again, we're not really covering things like activity diagrams that the block has to execute, right? So this is more, here we're really talking about direct behaviors on the block itself. And so we have essentially two things we can do. We can specify operations, which is like software, right? If you thought for, I guess, firmware, you could do it as well, model them as an operation. Where something that generally speaking is triggered by synchronous request. So you call a particular function, which could be, let's say you're implementing it in C++, for example, right? And so you have a call that goes out and that performs something, right, that the block supports, in other words. And of course, like any function call, it can have input and output parameters, right? And if you're familiar with UML, it looks exactly what you would specify as an operation in UML. So SysML doesn't really do anything different from a software perspective, right? And I'll show you how to do this in the tool. Now for receptions, let's see, we had receptions. Yeah, okay, so we'll take a look at those in a minute. But for receptions, essentially what you're saying for a given block, then it says, okay, when you declare a reception on a block, what you're saying is I'm interested in being notified when a signal itself triggers, right? When a signal happens anywhere in the system that that is generated right by the system itself from any other block. Technically, it could be a by its own. The same block could be actually registering interest in its own signals, I guess. But any signal that fires, from anywhere, right? I'm interested in that. Let me know. So it's like in a publish subscribe type pattern, it's like basically subscribing, right? And say, okay, whenever that signal fires, I want you to basically send me a copy of that, right? Let me know. And then the parameters, so the tool will automatically make sure that the parameters of the reception, right, or match the attribute. So if we look at a little example here. So let's just create a signal. And I showed you some examples, right, from that military vehicle with signal attribute. So this is the one place when you go to the features window, right, you have the first tab here called attributes. So in this case, for every other place, we always use properties, right, in terms of like SysML properties on blocks, for example, or on value, on interface blocks, etc. But for a signal, then we're actually using attributes, right? Just because of the UML inheritance. So here, for example, let's just say that, maybe we're being passed the oil temperature, I misspelled that, oil temp, right? And then, that could be, let's just keep it simple. We'll just use primitives for now, right? And just say, okay, this comes in as an integer or as a real number, I guess. Yeah, it could be a real number. And then let's just say that that same signal is also going to carry the engine temperature, right? So let's say engine temp. And again, we'll keep it simple. We'll just do real. Not sure why the tool kind of sorts it that way, but all right, pretty simple example, right? And we can call this thing temps, right, temperatures. All right, so we have a signal somewhere that will get generated. So how does a signal get generated? That's where we go. Tomorrow we'll go into activity diagrams, right? And I'll show you how to model the fact when and where, because you have to kind of model, define when and where does some block somewhere, right, actually generate that particular signal. When does it fire, or how often does it fire, etc. But for now, we just know that the system somewhere, somebody will actually generate that particular signal. So let's just say that this block 34 here is, when that signal fires, right, it's interested in being notified because it needs, in order to do its job, it needs to get a, I don't know what I did here. I can see I used the wrong, I used the default one. So let's do it, but be consistent. So we have, right, it's interested in being notified what's the current car or vehicle oil and engine temperatures. So how would you model that? Well, what you're going to do on the block, you're just going to go to receptions, and you're just going to click on, you can't type anything in. I don't think the tool will let you anyway. You just click on the three dots, and the tool then automatically says, okay, what signal are you interested? Because it's a one-to-one mapping, right, between the concept of a reception and a signal. So in this case, I'm just going to go into my sandbox, right, package one, and it filters it out, right? The only thing I will let you select is one of these signals. And then here you kind of see, right, the real, then real and real. By default, when the tool shows you operations or signals like that, right, or receptions, they only show the data types, right, which is, and they do this because they don't want to take up too much screen real estate. But in a sense, if I didn't have the signal on the model here, and you look at this, you say, well, okay, temperatures, right, temps, okay, real and real, but which is the first one? What's the second one, right? It's not, it doesn't convey the full meaning of what's happening here. So what you can do is you can go again to the compartment. Is it? Yeah, compartment visibility, I think. No, it's not compartment. Sorry, it's not compartment visibility. It's trying to see how they. Oh, I think it's at the diagram level. I think you have to do it at the diagram level. When you go under features on the diagram level, yeah. So you go, so for the whole diagram, you can't do it individually. At least I don't think so. Where you go see for an attribute, they show you name and type, which is correct, right? You see the name of the attribute and you see its data type. But for operations, what the parameters, right, the inputs and the outputs of an operation, they show you the the type only. In other words, the definition of, but not the actual name, right? So just come in here and say full details. You could sort of show the name only, but then without the type. But if you don't mind sacrificing a little bit of screen real estate, then right now basically say I know, okay, so the first parameter I'm going to get right is going to be my oil temperature. Second one is the engine temperature. I don't know. It's what would be another kind of temperature that we'd be interested in. I don't. I can't think of anything top of my head right now. But let's just say there's some other temperature, right? Or maybe it's external temperature, right? So external temp, and then it will make it the same thing. Select type. We'll go libraries. Right. We'll go real. Okay. So yeah, now I have 3 temperatures. Right. I just updated the signal. Guess what happened here, right? It's automatic. Right? That's the tool's responsibility. If I delete one, they'll take it out, etc. So they have to map because it has to, it has to literally match, right? That this is what you're going to get, and these are the properties that come in when you receive that particular reception. So that's on the side of receptions. If we look at operations, I'll show you as well. All right, so that's going to be pretty much like like a standard function call. Again, we're not really specific in terms of the language, where we're not saying, oh, this is a C++ function at this point. We're just basically giving it generic names, right? So let's just say some operation, some function, let's say some function call, right? So here now we're in the operations tab, right? And you give it a name. You could technically, you could kind of try to fit all the details of that in inside here, but it's kind of a very awkward interface. So usually what I do, I'll just give the name here, and right, so it just creates the function. And then if I need to say, let's say the function is going to take some input and output arguments, for example, rather than trying to do this here, which is really clumsy, I just you can right click on that function, and I think you say properties, right? There's also, I think, an F10 function key. Let's try that. Yeah, there's an F10 function key if you remember that, but if you don't, they don't really tell you that, but I think it's just like properties, right? And so now it's a little bit easier, right, to actually, because now you have a separate tab, right, to enter your, because some of these functions may take, 3, 4, 5 different, right, arguments, software functions. And so now let's just say, okay, argument 1, right, is going to be same thing, right? You're going to specify what kind of maybe it takes an integer, right, etc. Right, let's do a second argument. By default, if you don't say anything, then these arguments are input arguments. Matter of fact, you'll see that direction in. Let's say this one is going to be maybe a string, right? Oops, not this one, wrong string. It's going to be this string here, right? And then, and you could do output. Of course, you can have a return value. I mean, a return type, right? Void is kind of basically saying you could keep, void. I think is like C, very C specific, right? C language, C++ as well, C# I think as well. But it's not every language, has a concept of void. So you could just leave that blank if you don't want to make it language specific, unless it has something, right? And then you say, oh, it returns. Maybe it returns a Boolean. Let's just say it actually returns a Boolean. But you could also specify that, out, maybe there's an output parameter here, out1, that you're specifying as a, let's say a real number, right? So you're returning a Boolean, but also returning, let's say a real value to the caller, right? And then in that case, you would say, right, could be in, out, where you're passing it in, but you also expect an update back, or maybe it's just an out. So this is now standard software programming, right, that you're doing, but you're doing it in a language neutral way. Right? We're not really tying ourselves to a specific implementation language. And then these functions, again, how would you show when and where this particular function gets invoked, who invokes it? Again, we can do that in activity diagrams. We'll see that tomorrow. At some later time when you guys are ready for that, we can also do sequence diagrams, right, to show how one, from a software perspective. Sequence diagram only matter for software. Activity diagrams, you can make software with hardware, with firmware, with that's the power of an activity diagram. It is not dependent on what particular implementation technique you use. We're dealing with mechanical things, you're dealing with electrical, it doesn't matter, right? Everything can be represented in an activity diagram. But sequence diagrams are going to be software specific to say, okay, you're calling this function on block 34, which then in turn calls, let's say, this other function on block 32, which then turns around and calls this, this is a poor example here, but right, calls this function on the power supply, et cetera, et cetera. So that would be the concept of sequence diagrams. So those are the two from a behavior perspective, right? How you're going to model these. And then we'll look at directed features in a second. So here's let's see, operations compartment. Yeah, there's a non-compliance here from the Sparks. It's no big deal, but it actually should be a label on top here when you enable the compartment, just like here in my example. It should actually say operate. See here it says receptions, but then when it comes to operate, and again, it's because UML doesn't have that, and they don't want to make their code specific to SysML. I mean, that's all it is, right? So it should say operations, but it doesn't say that. That's no big deal. And so now you have on this particular block, right, you're going to see the operations like we just did, right, with the parameters and the return type, etc. So you get a more concise, right, representation here of of the operation, right? You kind of see, so you can kind of you see the full string here, but it's just not easy to model it here. Scope, by the way, is a UML concept. Of course, when you deal with code generation, whether something is private or public, etc., is important. You kind of see the little plus signs here, but technically they actually shouldn't be there. And I think there's a way on the diagram to turn that off, I think. Suppress, show property, show stereotypes. I thought there was. I'll have to take a look at it. I know there's a way to not show the plus signs. I mean, it's not that they hurt, but they're not relevant to SysML. It's like, public class manager. Yeah, because it basically means public. And basically in a SysML world, it's like everything is public. In other words, if you open the door, like I talked about earlier, then anybody can come and call this function. If you want to control, like say, okay, let's say, for example, you say, well, block 32 is allowed to call this function, but nobody else, right? Then you'd have to create ports with an interface on it between block 32 and block 34, where this particular signature is on that interface, right? And then okay, so block 32 is allowed, but nobody else is, because nobody else has that key, right, to call that function. Let's see what else. So this is kind of summary, right? What we just did. Again, here's like the F10 function key. So we just type in the name, so the tool has something created, and then you can enter the properties for it in more detail. Unless some functions just there's just a name, and they take no parameters and have no return. Okay, so in that case, right, you can just do it directly in here. SysML primitive, right? Value types, we talked about that. Yeah, so here you can also change the direction, right, in and out. And let's see, the access complete set. Yeah, but if just want to make the typing, right, the editing a little bit easier, I just always hit the F10 function key and just do it in a dialog. I don't like dialog boxes, but it's a little bit too concise, the interface, to make it really easy. And again, yeah, you could put multiplicities, right? By default, when you put an input or output parameter, the assumption always that it's a single value. But if it's like an array, right, then you specify multiplicities exactly like you guys did on your part associations, right? You can say, 0 to 1 if it's optional. You can say, it's 0 to many, like you pass in an unlimited array of values, etc. So now we're looking at receptions, right? A block of receptions like we just did. Now, one of the things that we're going to cover here is the concept right after this. We're going to talk about directed features. Directed features are not, well, let's put it this way. I mean, they're definitely, it's a very useful concept, and there are definitely cases where you'd be using it. But if you, like, for example, the way here, when I specify my reception and when I specify my operation, I did not give a direction on it, right? And then a lot of times you won't, because implicitly, when you put something like this on a block, right, that means that this, what the tool assumes is like an implicit direction, or what SysML assumes really is an implicit direction, meaning that this block 34, I provide this function. In other words, you can call me on this function, right? Just like on a class, a C++ class, if you define a function there, that means that if it's available, right, to the rest of the world, then somebody can call it and use it. Same thing on the reception. Basically, it's implicitly provided, meaning that it is provided to block 34. Right? That's what provided means. Not that block 34 is the provider, because for a reception, you really have, if you think about it, you have two sides to the fence. Right? It's like, okay, one block somewhere, right? Some component of your system is actually responsible for generating that signal. So in that sense, if we said, like, for example, block 34 is the one who's responsible for actually producing it as part of its behavior somewhere, right? Then we would also put a reception here, and we would do the same thing, right? We're going to go inside here, and we're going to point it to that same signal, right? Let's just move this guy out of the way now. So at this point, right, this looks like, okay, right, the way it's modeled right now, right, this would mean that both block 32 and block 34 are interested in being notified, right, of these temperatures, but that would not be true in a sense, except if block 32 is kind of interested in its own, it can actually mark it like required and provided, right? That would be an example of doing that. Well, let's assume block 32, it knows, right? It already has the data, so it doesn't really need to be notified again. But it is the block that is responsible for producing the signal. Well, so in this case, now we need to make a distinction, right? We need to basically say, okay, well, which one is the one that's going to produce, and which one is going to be the one that is, in essence, subscribed to it, or from a publisher. Let's call it this one the publisher, and this is the subscriber, right? So in that case, what you need to do for reception, I would come back here, and you're going to see what stereotype. Again, I'm going to take out scope just to save some space, because it doesn't mean anything in SysML. And oops, sorry, let me go back here. That's probably why the tool doesn't. Okay. So I'm going to click on the three dots and see one of the things you can specify there for reception, right, is the direction. They call it a directed feature. So in this case, I'm going to give it a directed feature. And the tool doesn't quite know at which direction it is. It could be one of three things, right? Provided, required, or both. So it's going to just assume that it's provided. But now I can go to the properties of that definition, and the fact that I made it a directed feature, then automatically this property gets added, and I can change the direction and say required. Right. So the nomenclature can be a little bit counterintuitive, because you could think, well, isn't the block that generates the signal the provider, and the one that basically is interested the required, right? Because to me it sounds counterintuitive, but that just that's how the specification looks at it. So what they're trying to imply, right, with require, is that this block requires other blocks, at least one other block in the system, right, to take notice, right, to be interested in the thing that it generates. And versus here, when we say, so here I have not turned this reception into a provided, because it's provided by default. If I want it to be consistent, it probably makes more sense, right, to actually also change this one, but we'd have to first turn it into a directed feature as well. So let's do that. Stereotype. All right, we're going to turn on the same flag. In this case, I do not need to flip it around, because the tool just picked provided by default, right? And that's basically it is provided to it, right? It's provided with that signal. That's the meaning. That's how they look at it. So I know it may not be intuitive, but that's how they do it, right? That kind of makes sense. That whole concept of required provided, and you have the same problem. I mean, not problem. They have the same concept for things like even properties, right? Or operation. Same thing here. The assumption right now is block 4 supports that, but the block code also say I have this other operation here. Let's do some function 2. I'm not going to go and specify it again, right? You just assume that it has no parameters, but it needs to call out, right? It needs that to be some other block provides to it. Then I can say it's a directed feature, right? And in that case, it would essentially require it, right? So we would then go in here, some function 2, and let's see, on the property window, right? We have this extra property that automatically popped up now, all right? And we can say, okay, it is required, right? So in other words, now this particular function now, function 2, by the way, this is another kind of a bug, if you will, that I think the directed feature should be in its own compartment. I mean, it's just graphical, right? It's just display issues that the tool has, but so that should be a line here that basically separates these guys out. But anyway, so basically now when you look at it, oh, block 34 will need, right, to be able to call. Now there is a relationship between the two blocks, so that means that block 34 has visibility, right, into block 32, because block 32 is kind of its parent, right? It's a container. And of course, block 32 has visibility into block 34. So when you're part of a hierarchy, right, it's kind of like there's a trust level, implicit trust level, right, between blocks, components that are part of the same hierarchy, because you trust your own components. But now that this, right, it basically says I provide this. You can call me on this, but by the way, in order for me to do my work, some other block, right, which I have not specified yet, is going to have to, and you basically do it by name. So not the tool will never validate any of this, right? But logically, at the end of the day, when you're done with your design, there should be a block that has a relationship with block 34 that has this exact function, this signature on it being provided, right? That would be to be consistent, right? Does that make sense? That kind of like, I need somebody else to do something for me versus, this what I do, right? And the ability to express need versus, what I do, what I provide.
Yeah, I'm kind of making sense of that.
Okay, good. So here we have like, a block with, some, again, it has a bunch of receptions, right? Some are required, some are provided. So in other words, it will produce, right, some of these receptions. And right, so again, the receptions, right, the block wants to receive, then you say provide it, because provide it to me, right? So this one, it wants the status ACK. I think that's actually the only one. It wants to receive that, but it will be, the surveillance system itself will be the producer, if you will, of these other signals like alert, status report, system off, system on. So signal receptions, right? I showed you guys how to do them. The tool will automatically prompt you for the signal. It will look to see what attributes you've defined there, and automatically then so keep these definitions and this in sync, right? That's their job. So directed features, right? We just saw a couple of examples of that. So what does it apply to? You saw me do it on an operation, right? You saw me do it on a reception of signals, but you can also just do it on a standard property, right? So like, for example, here, we had some two properties here. I could make this into a directed feature as well. If you drag and, so these are existing ones, right? But when you drag and drop a directed feature on a block, you'll get the choice, if you do want to do it that way, right? Otherwise, you can create the property, create your operation, and afterwards, right, just set the stereotype. I mean, either way. Notice that reception is not in here. For reception, you always have to create them the regular way, the normal way, and then afterwards, right, you set it. I can kind of understand why they don't do that directly from the toolbox. So here again, I could just go and to say, okay, this distance thing, right, is something I need. I don't have that information myself, but I need it from some other block. So therefore, on the property side, I think we need to go to element, right, on the stereotype for that element, right, and the tool will list all the SysML stereotypes. There should be directed feature, right, for a property in here, boom, right, and again, it's right, and it says in this case, it does say provided, right, if it needs it, I would need to change it as well and say, no, it's, I don't have that information. Some other block is going to have to give that to me. I'll need to read that, right, from another block somewhere. And you could have provided required. I mean, that's kind of a strange one. I haven't seen any real life examples, right, of provided required, but I'm sure there's some out there. So here you see, for example, the transmission, right? So you can say, well, I have a function, right, that you can call called select gear. So you can tell me, like, go to second gear, or tell me the gear to go to. But in order for me to do my gear operation, I'll need to find out the torque. So torque is not something that the transmission as a block or as a component of the system knows, but it will need that from some other block. So it says, okay, you can do this, but I will need to go and call get torque on some other block. Right. And then in terms of properties, right, it says, okay, I can keep the temperature. Actually, that being another good example, right, of temperature of the transmission temperature, right? But I will need the some other component to tell me the spline, right, geometry of the spline. So just little examples like that. Control. So you can also, like, of course, in an interface itself, right? So you can also put directed features, right? This is just a declaration, right? But you could put, in this case, they're all required essentially. And so, basically saying that the interesting part is, okay, from an interface, we know that the interface is like neutral, right? So it's just a declaration. So it doesn't do anything itself. So, and it's an interface block. So we know that it will need to go to a port, right? Not to a block directly, right? But to a port of a block. And so if we say, for example, block A is going to talk to block B through this interface, then clearly one side, and you have a declaration like this, that means that one side, right, is going to be actually the provider of all these things. And the way this is all required in this particular sense, right? Then and the other side, using the exact same interface declaration, is going to have to flip the logic around and say, okay, well, I'm the provider, right? Because A and B are going to talk to each other through this, and only through this interface, right? So the only things allowed between those two. So one is going to have to play the role of the provider. And so what you're doing on an interface is you're just declaring, one side of the fence, because you have to, as an interface, you can't specify it from both ways, right? In other words, if you have the concept like in a messaging system or service-oriented architecture, right, you have a requester and a provider. There are two roles, right? And of course they're complementary. One requests something, the other one gives. But here we're putting an interface in the middle, and since the interface can't be looked at from both sides, right? When you declare an interface, you always look at it from one. It's arbitrary, right? You look at it from the A side or from the B side. And let's just assume that we're looking at it here from the A side, right? And when we declare that something is required, but logically, the B side, using the same interface, is going to have to literally flip the logic around, right? Because otherwise, if they both require, nobody provides. So you wouldn't be talking to one another. So we'll talk about that more when we deal with ports. I'll see how far we get today. But so think about that and keep that in the back of your mind, right? Because an interface is just like sitting in the middle. It's neither A nor B, right? So it's neither provider nor requester. It has to be a neutral declaration. They're thinking about changing that whole concept a little bit I think in version 1.6 of SysML. But so this is kind of the way UML does it as well. So that it is what it is right now. So directed features, like I said, yeah, you could drop it directly. If you know you're going to use a directed feature, right? It's not like after the fact when you think about it, you can just drop it directly, right? And the tool will always assume provided by default. And then then you can decide which side of the fence you're on. So we did that. And then if it's an operation, right, that you drop it as an operation. I mean, it's kind of a funky interface they throw up because you just have to put the name and the type there, and then you still need to go to the other feature window to do it. So for operations, I never actually do it from the toolbox. I just always create my operation, then change the stereotype, just because the interface here is quirky. And see what else. Yeah. That's kind of what we already did, right? Directed features. For a reception, right? Like I said, for reception, you have no choice. You always have to create the reception first. Then you go right and click on the on the three dots here for the stereotype, and then you change it, right? So if we take a look at some additional properties, right, or the full set of properties that you can have on a block, we already seen a bunch of them, right? So you guys remember when you did a little exercise, the tool automatically created part properties in response to you using the black diamond, right, the decomposition relationship, the part association. You saw also the tool create parts automatically. Or, by the way, the term property and part, I mean, technically there's a difference, but for the, I mean, just you'll see the term like part and property used almost interchangeably. So just consider them one and the same thing. Under the covers in the spec, they make some distinction, but I wouldn't, don't worry about it. So you have a part property, you have a reference property, right? That when you guys, again, in the exercise, right, remember you had two reference properties, like one to the brake pedal, right, where you use a regular reference association. And then the other one, I think, was from the power subsystem to some other block, right? So you saw the tool automatically creates those. They manage them, right? You could value property. Okay, so let's take a look at constraint properties are part of the parametrics. So we're not going to cover them in this training class, but value properties, I think I already see here. I mean, see, these two properties now are considered value properties. Why? Well, because when I created the property, right, I essentially and the tool then asked me what's the, or at least I specified the data type, right, like here, UN16. I went right into my library and I picked a value type. So that automatically makes it a value type. Now, if you, let's throw some other property in here, right? And let's say that we have this block, maybe this block one here, right? So let's call it, I'm not going to populate it, right? But let's assume this is some kind of a data structure, right? A little bit like kind of similar to a signal, but it's not a signal, right? It's just some data structure with multiple fields in it. And so now I can kind of, in this property here, if I go into the type, and I'm going to say select type, I think, what did I just call it? Something struct data here, right? Structure. All right. And save that. Right. And I just make that, right? So it goes into its own, right, into its own bucket. It's a property, it's just another property, but in SysML, they make that distinction, right? They want they want to clear that this is typed by a value type, right? It's kind of an official type definition versus anything else, but you use a block as its type. Or you use, if I were to, again, not that I recommend that, but if you guys just say property 2, and then you go right directly in the dropdown and you use one of the tools, built-in data types, I mean, that will show up here as well, right? So, I mean, it's just a way to separate out, right? The kind of the type will separate out into compartments based on that distinction. What do you type it with? What do you, right? What data definition do you give to that particular, or what definition in general, right, do you assign to that particular property? That's why they make that distinction. So that's a value property, right? That's it. So part we already seen, reference we already see. This is just more like for backup. This we already covered that. It's just more to be complete. So what we're going to do is kind of have an exercise that kind of summarizes a little bit everything we've seen for the last couple hours. And you're going to put this in exercise 4. So if we look at the database here, right? So you guys did your first one up here, exercise. So now we're going to skip a couple, right? Because it's, there's only so much time we have. But this one is an interesting one. So we're going to go and do an exercise 4 on the internal combustion. So I pre-created the diagram. I don't think there's anything in it. And so that's just, you open up the diagram, right? Yeah, so what we're going to do is we're going to create, in this case, we're going to create an interface block, right? And so obviously a little bit later, hopefully still today, we'll go into ports, and then at some point we're going to use this, right, to associate this interface with a port. But for now, you're just going to create the interface. So that will give you some practice in terms of, these are just two operations. And remember, the tool doesn't show you the label, but I mean, that's what they are. And so this is the name of the function, right? And one takes a throttle position of type real. Again, I'm using my library here to actually type these, to actually associate a real value type, right, with these arguments. There's one input argument. None of these returns anything. So you can leave it blank or you can leave void. The tool will put void there automatically. And then there's another function called set mixture, right? And that's going to take one argument, again, input argument of with the mixture of type real. So just to give you some background, right, this has to do with the internal combustion engine, right, of the vehicle. So this particular interface is going to be, rather than making this a very long name, I just said basically internal combustion engine, right, ICE to power control unit, right? So that's going to be the interface. So where the internal combustion engine communicates or talks to, so to speak, with the power control unit, they're going to basically talk through this interface. That's going to be the contract between those two, things, between those two components of the vehicle. And so the other thing to do then in your exercise is create like 3 properties. Actually, create 4 properties, if you will. So, these 3 are just regularly provided. So there's is knocking, right? The RPMs. You can kind of tell just looking at the interface and the fact that this is provided, right, that it's the internal combustion engine, right, that's going to be, if you will, on the implementer side of this interface, right? I hope that's kind of should be obvious, right? It's not the power control. You can't say set throttle on the power control unit, right? It wouldn't know what to do with it. But again, remember that whenever you define an interface, you have to look at it from the perspective of the internal combustion engine or the power control unit. And so in this case, right, it kind of, it makes sense. I mean, so could I have changed this interface to look at it from the perspective of the power control unit? Absolutely. But then this would be required, right? This would not be provided, be required, provided. The way this interface is now specified, it made more sense logically, right, to look at it, because there's like 1, 2, 3, 5, 6 different things, right? 4 properties and 2 functions that are part of the interface definition. So it made more sense to look at it from the side that provides most, right? In this case, the internal combustion engine has 5 of the 6, right, are provided by it. In other words, it provides the feature to change the throttle, to change the mixture, right? And it also keeps track of these 3 properties that other parts of the vehicle are interested in. What is the engine knocking? What's the current RPM reading? What's the temperature of the engine, right? So from that perspective here, these 5 are provided, but the internal combustion engine does need to know if the power control unit, the control is on or off, right? And so in that particular case, right, this is another property, right? It's just a property. You could create it just as a, the same way as you do those 3, but then turn on change the stereotype on it manually. Or if you want, it's up to you, right? You do a directed feature, you drop it not as an operation, right? Drop it as a feature. And then the tool will automatically put the stereotype there. And then the only thing you'll need to do, because they will say provided, right? I mean, they just make a guess, right? And then you'll have to change it so that it becomes required, right? So one side provides 5 things, requires another, looked at from the internal combustion engine, but the same interface then looked at from the power control unit will be, 5 things that it needs. That is, right, it needs to call this, it needs to call this, and it needs to read, right, these values, and one thing that's going to provide. Does it start to make sense? This whole thing about, interface being in the middle, but then on one side or the other, right, playing a role in terms of how. So technically what it means is that when you have A and B, right, that talk to a particular interface, when you define the interface, you have to be consistent, obviously, right? So you always look at it from one side or the other. It's arbitrary, it's 100% up to you, but you're going to define it from one side or the other. When we actually use, the interface, when we connect these 2 ports together through this interface, we'll have to flag one of them as being being compliant with this interface exactly as it's specified, and the other side will have to tell it, hey, you're the one that's going to reverse the logic, right? So anything that's provided here becomes required to you, right? Anything that's required becomes provided to you. So I'll show you how to do that once we deal with ports. But that's the logic, right, that you have to like start getting used to. Does that make sense, exercise-wise?
I think so, yeah.
Okay.
So Frank, on note number 3 of the if the directed feature type is if the directed feature type is, sorry, what if the directed feature is typed by something other than a value type, it will appear on its own directed features. I think I might have missed something. How do you type it as a value type?
Right. So all of these actually here, those three, actually they're all four, what are actually typed by. So in other words, you assign the type like we did. Where's the guy here? Which one did I use? Like, for example, here, right, when you create a property, right, and you assign a type to it, right? So in this case, I didn't do a value type, right? So that's why it shows up in its own. Now, if I make, like, for example, here, technically speaking, right, you have a set of directed, let's actually make, see, if I take this property here and I make it a directed feature, so just trying to explain what I'm saying here. It's like the tool does something that's technically, I mean, I can kind of understand what's happening, but so, so you see now, because I made it a directed feature, it shows up in its own property, right? Or you could say, well, wait a minute, this guy here is also a directed feature, right? You could see it. Why isn't it in the same compartment? So the tool has that conflicting, because the spec says if it's typed by a value type, you need to put it in the values compartment. But the spec also says if it's a directed feature, you have to put it in the directed features compartment. And it kind of like well, what do we do? Right? Because I can't put it in both places. And so they just, if it's, so their decision was, if it's typed by a value, it's going to stay in value, even if it is a directed feature. That's just, so if you look at it, it's got to say, well, now how come this directed feature is not in a compartment called directed feature? Well, that's why, right? That's because the tool decided, or the vendor essentially decided, right, that since I can't put it in both places, they're just going to, you continue to put it in the value types. Does that make sense?
I think so, yeah. But so the only way for it to be there is to initially declare it as a property and not as a directed feature, and then turn it into one.
Well, the only way that it's gonna, so when you have directed features, they should always show up in the directed feature compartment, right? So,
yeah.
But if you type it with a value, then the tool is going to put it in value. That's all. I mean, that's so. If you say, well, that's technically wrong, I mean, you could, the vendor could probably argue with you and say yes or no. But it has, like I said, it has two conflicting imperatives. One that says it should be here, and the other one says it should be there. And it's like, well,
Yep.
it can be in both, right? So if you're confused, it's like, why is that? Because it says directed feature, and directed feature does have its own compartment, yet I'm not seeing it there. Well, okay, guess that's why. Now, if I didn't put if I used anything else, if I put a block there, right, as a, or like one of the tools primitives or anything other than a value type, then it would have shown up, right, in its own. It would have shown up exactly like this guy here, right, in its own little compartment. So that just, just to clarify that.
Okay, thank you.
Because you may decide not to put a value type there, right? So it's, and then it would show in a different compartment, so the picture would look different.
Yep. Yeah. Exactly. Yeah.
So let me know when you're done. Or if you have any issues.
So Frank, I'm struggling a little bit with the property thing. So every time that I'm clicking property and dropping it onto the block, it's dropping an actual property block, and it's not looking like the slide you got there.
Right. So let me show you again an example here. Right. So move these guys out of the way. Right. So if let's say I want to add another property. So the tool, it doesn't give us a way. Well, maybe you can do it through the features, and I haven't tried it, but see, there's no such thing as like new parts in here, something like that, right? Or new property. So when you create a property, like you said, right, you have to drag it from the stencil, right? And then it's going to show up graphically, right? And then you assign a type to it or whatever. And so, but when you're done with it graphically, then typically, let's just give it a type quickly. And we'll just pick Boolean, right? Something like that. And then when you're done with it graphically, you just hit the delete key, not control delete in this case, right? So basically it will, and then automatically it will show it to you, right, in a more concise notation. It's like but you have to create it as a graphical like child element first. And then when you hit your delete key on the keyboard, then the tool says, okay, well, you don't want to see it graphically anymore, right? I'll put it in, where did it actually go in this case? Probably if you, oh yeah, it went right here, right? So it will put it in the right compartment. If you wanted to see it graphically again, sometimes you may want to do that. Then what you do is you go to features, and I would say, okay, see if I click it here, remember that right on the part, so you can make it visible again, like in an IBD. The reason sometimes you may want to do that, let's say this other block here, there's a little trick, right, that you can play sometimes where you have another block and you say, oh, you know what, this block also needs a very similar property, right? Maybe not exactly the same name, but the same data type, whatever. Oh, that's fine. Let me, oops, wait, hang on, because I didn't do that right. Let me, first of all, we'll make this one a little bit bigger, right? And let me take this guy and do a control key down, right? Drag and drop, clone it, right? So, okay, maybe this is, the name is different, but at least it's get the same type. So that may be the only reason sometimes where you leave something a little bit graphical, because you can quickly drag and drop it, right? And like clone it into other blocks. Other than that, I really don't see any reason to leave it graph, because it takes a lot more screen real estate. Right?
Gotcha.
Yep.
All right, I don't know if anyone else is completed, but I don't want to be the one to hold us up here. So I think we can move on. Everyone else is done.
Is anybody needing a little bit more time or having a question about it? All right. So we'll come back and we'll actually use this in a I think our next interface. I'm sorry, our next exercise. This is just, these couple of slides are just a recap of things out of the spec. It's more there for your own education, but we already, right, we use part associations, we use part, so it's some of the details coming out of the spec. There is a concept, by the way, so we haven't really used that much. I'll just point that out very quickly. So you kind of, so the ones in terms of BDD, right? We've been using part association, reference association, which is sometimes you use generalization, right? For hierarchies, we talked about that as well. So you have this other thing called a shared association. It's like, okay, what's the difference, right? Between, so if you do a shared association, basically, let's say between, well, let's do a shared association between these two blocks here, right? Then, the tool, of course, will create a part for it as usual. But the meaning is that, okay, I have a relationship, I have a usage relationship from, let's say, block 34 to block 35, but I don't own it. Okay, well, then logically, isn't that exactly the same as reference association? And the answer is yes. right? So in terms of the semantics, right, of the language, I mean, it really is. I mean, maybe there's some very subtle distinction, but I mean, for the way the tool acts it will basically treat it as a reference association. And so for that part, because it basically means that some other block also, right, it's shared. That's the meaning of the word shared. It's like I don't own that. It's also I'm sharing it with some other block. Well, okay, if you have a reference association, you're also sharing it. I just don't have a good example. I know in software, this one is called aggregation versus composition, and like in the software world, that has some big implication, because like composition basically means that what if like a UML class, right, owns another class, and you delete the owning class, then you have to also delete, right? Like it have to do with lifecycle propagation, right? So you delete the container, then all the parts have to go as well. See, but SysML doesn't have these connotations in terms of like lifecycle management. So I don't know why unless you guys can come up with some reason that you want to make a distinction between this guy and this guy. But if you don't, I would say just to keep things more consistent and simple and not confuse the hell out of anybody looking at your diagrams, just use part association and reference, because reference and shared really semantically boil down to the exact same thing. So that would be my recommendation. So the only difference, right? You have black diamond, right? And so reference, that's why you see it in the spec as well, right? They show you could model it like this or model it like that, and it has the same meaning. It just maybe personal preferences or. Then, so what kind of other relationships, right, can you use in a BDD, right? So item flow we're going to talk about a little bit later, but actually you shouldn't really use it in a BDD. It's more the intent is more to use it on an IBD than a BDD. Containment, right? Nesting. So blocks to be like like physical connectivity, like a block within a block, like a child block, right? Which you could do in the tool, because you can literally, just like with requirements, remember, I could just take this block and move it under this block, and it would become, right, a child block of it. But you could also model this kind of parent-child, which is not the same as decomposition, right? Because it doesn't have the same implications in terms of the tool creating parts and stuff like that. But it's more like to show, okay, there's kind of a parent-child relationship, but between the blocks, but it is not part ownership relationship. So it's kind of a strange duck. I see people do that sometimes when you have like subsystem, and then they have the components within the subsystem, and they're in the same folder structure, and then they want to move, like to show the components of. So in other words, they're kind of doing a decomposition again in the browser structure, like they're doing here. I don't know. I mean, it's not wrong, but I think it's like overkill, because you have to keep doing it, right? And also, I mean, you could have ownership where if you have like a block that has multiple subsystems and it owns these subsystems, a lot of times the subsystem themselves will go into separate folders. If you remember the folder structure I showed you guys right yesterday, where it makes sense to have every subsystem in its own little, nice bucket with its own requirement and its own value types and its own signals, and then that whole thing breaks down because this subsystem here is in a completely separate folder. So containment, I mean, it is here. I've never, I mean, I don't quite use it within a BDD. Not sure what I would try to represent, other than maybe a graphical representation of a parent-child relationship, right? But it has, the tool is not going to do anything. It has no real impact from a SysML perspective. So I'm not too sure about using that particular thing. But it is part of the language, of course. So it is there. You could use it for something called nesting. Dependency, if you have some relationship, sometimes that can be useful if you have a relationship, let's say between two blocks, but you don't want the tool to automatically create parts or anything like that. You would just say, well, there's some kind of dependency in the sense that if I change one, I may have to go revisit the other. But it's not like that they're not associated together. I don't have like part association or reference association already, right? It's just like they're two independent blocks, but there's yet some kind of, from a semantic perspective, right? Or from a, some kind of traceability perspective, you want to just have a generic relationship between them two that doesn't cause the tool to do anything funky, right? To just have no side effects. So dependency, you can always create dependency between two things, and that's neutral. generalization we've already talked about. So that's about it. On the IBD side, right, binding connectors we're not going to use because it just basically has some very special meaning. So for our training this week, we're just going to stay away from binding connectors and just do regular connectors between ports or parts to ports, as the case may be. So let's talk about ports for the remaining time that we have today. It's a very, very interesting concept. The concept exists in UML already, and in UML we use it sometimes, to show like deployment diagrams, right? You have like servers talking to other servers, and they literally like connect to, port 80, port 443 or whatever. So, that's a concept that and you could do that in SysML. You could use that generic port concept if it makes sense. But so the idea of a port conceptually, right, it specifies an interaction point, right? And in the current context of SysML, it's an interaction point between blocks, right, where external entities can connect, right? So it's basically, like I said, it's like having a building and you have doors or windows, right? And of course you can have more than one door, right? So so a block basically can have multiple doors, and it's a like door one, right, is when I talk to block A. When I communicate with block A, and this second door here is when I communicate to block B, which has a very different purpose, right? And I want to make sure that I understand and control how I interface with these other blocks, because each one has its own kind of usage, right, and its own intent behind it. So that's the idea of creating ports, is just like creating interaction points, right? So when you create them graphically, right, they could be on the boundary of a block. I mean, you're going to see 3 ports, right? Port, proxy port, full port. Proxy and full port are specific to SysML. This is just a generic UML port. Ideally, I would try to stay away from the generic port because it just goes back to just standard UML usage. But it is in the spec that you're allowed to use it. So the tool is not wrong in putting it there. But I think it's better to think about, so proxy port is a special kind of port and full port is a special kind of port. I'm going to explain to you the difference in a minute. So it's better to think about it and say, okay, which port should I use, right? Rather than just using one that's totally abstract. But I mean, that's fine if you do. So if I do like a proxy port, right, then I throw it on this block here, right? So that what they mean is like you could keep it graphically, like floating around. It has to like literally, you cannot move it inside, you cannot move it outside, right? It's by definition graphically how it's going to show. And in an IBD, then of course we always leave it graphically, because in IBD we want to like literally show, right, the connections going in and out. It's like a wiring diagram, right? So the wiring in and out of that particular port in and out of that particular connection point. When on a BDD, generally I don't, unless I want to again play some trick in terms of like say, oh, I want to clone this, right? Because these two blocks here are going to talk to each other through the same interface. So let me just clone this port, right? But I would first put the interface there and then use my control drag trick. Otherwise, yeah, once I don't need it graphically anymore. I just again, just like with the property, right? You hit the delete key on your keyboard, not control delete, right? Just regular delete, and the tool says, oh, okay, fine, right? I'll show you the more concise notation, right? And you'll see it as a proxy port here in this case. So that's the general meaning here, where it says, well, it can reside on the boundary of I mean, it can, right? You can leave them graphically; it's no big deal, but it takes up more screen real estate. So it's smarter, I think, to just not leave them graphically on the block, and then in a compartment. Remember that you could tell the tool, I mean, I'm not interested in seeing ports in a given diagram. You may not want to see, right? But you can always control. So if we look at compartments, compartment visibility, see, I mean, directed features, properties. It hasn't quite figured out that there's a port there. Let's see. Oh, I'm sorry, I put the port on here on block 35, so it's my bad, right? But yeah, so in here, if I look at this one, right, the same thing, right? You're going to see proxy port. So you always have full control, right, on any given diagram, how much of that stuff you show. You typically do not want to show everything on every single diagram. It's overkill, right? But depending on context, right, you decide which compartments to visualize, which not. The tool just assumes most of the time you want to see it, so you kind of have to tell it, hey, don't do that. promote the design, right? Reusable. So just like in standard object or any good modeling, object-oriented modeling language, as well as code language, right? You try to be reusable. So you try to make your design modular, right? And then having, but there's also kind of a security aspect into it, right? With interfaces and ports, because you can nicely isolate, right, what one element does to another, what one component does to another. So it gives you a level of protection, especially with software, of course, but maybe in the hardware world, not as much. But still, it's nice to be able to isolate, right, the touch points between these blocks. So yeah, you can have nested ports. I'll show you that as well. So there's two special kind of ports in this, which are specific to SysML. So I already talked about the fact if you use a proxy port, right, it's a one-to-one relationship with an interface. So a proxy port requires an interface block and a full port. And then you have the standard UML one, right? So let's look now specifically what's a full port. So a full port means that the connection point itself, like in this particular case, the connection point itself is providing all the functionality that another component would need, right? So it's almost like you're putting something on the boundary of this in a sense that allows sometimes to treat a particular component as a black box, right? And so okay, here's the functionality, right? The full functionality that some other component is going to need, but there's no need for me to do anything inside me, right? So it's because it will take full control. So this port here has to take full control of the of whatever the interface would be. And when I say interface, I don't mean interface block, but whatever, right? Whatever the other component connecting to it would need. Now, when you're dealing with hardware, to let you, for example, say that you have, I think I'll show you a little bit later the example of a camera system. Yeah, I have it actually. Let's take a look at it here. So we have a camera system where you have the mount, right? How it's actually, let's say, mounted on the wall, right? So the mount has like basically two faces to it, right? One is going to take the camera, is going to be attached to it, bolted into it, right? And then of course on the side of the wall, it's going to have, right, a set of bolts, right, that go into the wall, so you can actually put it up on the wall. So this is like, think of this as like the physical, right? I don't have a picture of one. Let's see if I can find one. It'd be interesting to put a picture there. But think of this, right, as basically the physical mounts or piece of metal, typically, right, with where the bolts will go in on one side. So on the wall side, we're going to use M10 bolts, right? On the camera side, smaller M5 bolts, just as an example, right? So each one of these is a port, right? But it is a full port. Why? Because that bolt, or this particular bolt here, I'm sorry, not the bolt, but the actual the bracket connection point, if you will, right? The camera left bolt as well basically is physically connected, right? So in that sense, you use a full port when there's absolutely, because the mount itself is just a piece of metal, right? So obviously it can't do anything, but you could also have cases where you have not some physical object, but some like component, maybe an electronics component, right? And it just has its own functionality, but it exposes some subset of functionality to the outside world, but yet the connection doesn't really go inside that particular component. It's like literally having a little plug, right, that you put in there. Maybe gets its power from this component, but it just has a plug on the outside that you use, right, to go into it. So there's probably some cases outside of pure hardware where you may want to use like a full port. Because that's basically the idea. Is the port itself has all the smarts, or all the whatever it needs to do, right, is literally embedded in that particular port. So I mean, so that means with a full port that you always have to type it, not with an interface, but with an actual block, right? Because the real behavior has to come from that block. So in this case, what are we typing these ports with? Well, we just have, because they're bolts, right? We just type it with the correct type of bolt, and we say, okay, so this particular port then is essentially an M5 bolt or an M10 bolt. And then when we actually look at the camera side, right, that what we do is, so that because the camera is going to get mounted right on that side of the mount, then we create a port as well, which is also a full port. And that particular port is going to be typed by the mount. Right, so that's why it was talking earlier about, I don't know what slide it was, nested ports, right, leading to nested ports. Well, you can have, this is one example of using nested ports, because when you when you type, a particular port with this block in this case, right, which happens to have 8 other ports on it, right? Then you can make the 8 ports visible, and you don't have to, obviously, right? But if from in a BDD, you don't have to. Here I just did it as an example model, but in the IBD, right, if I literally wanted to show, right, the connections, probably not, right, it's overkill, but then you would expose it to show, right, connections going into each one of these full ports. So it's like one port. I know this is like, this is a big rectangle, right? And yet it contains these other, small, small squares actually in this particular case. So but the tool has to give us a graphic ability, right, to do that, to make a, one port contain another port, graphically speaking. And then you have the choice, right, to actually have more than you. Again, in the property sheet of the features window, you'll have the choice to say how many of those do I want to display. So if I were to do a very quick example here, it's kind of something similar, right? So if I put a block on there and I call it mount, I'm not going to do all 8, right? We'll just say that we're going to put 2 full ports. So let's say there's only 2 bolts, right? And then so I'm going to put the full port on here. Let's call it bolt 1, right? I'm not actually going to create a block called with the type of bolt, right? To just imagine that we're doing a full diagram here. So we have bolt 1, right? And let's call this one bolt 2. So a little drag and drop, by the way, could save you a lot of time, right? Because you could just play this little trick of cloning these things. And now let's actually let's say there's going to be a camera, right? That would be the camera that would then, of course, have it be attached, right, to that particular mount. So it's going to have also a full port that we then going to type, do Control L at this point, and we're going to type it with this mounting that I just created. All right, so here's the port. So let's say that I do want it to show the, so this port has ports, because it's a port that references a mount, and the mount itself has 2 full ports in this example. So I got to be able to graphically display, right? So the first thing you try to do is, well, okay, I have to make this guy bigger, because how can I show, right, these same size squares in this little square? The answer is you can't, right? Tool won't let you, because graphically you're not, if you have a single port, you're not allowed to make it larger. But if you right click on the thing and you go on the advanced menu, you'll say set port customizable. And the only reason you'd ever do that is because you have ports within ports, right? I mean, there's really I can't think of any other reason to do that. So now we can grab this thing. Probably doesn't need to be that big, something like this, right? So we have ports, and so we know that this is, right, the full mount port. And so just like in the IBD, remember in your exercise when you had to go like one level down and get the parts, right, for another part, like part within part. Now we're ports within ports. How do I going to get the internal ports? Same thing, but we're not going to look at the parts. We're going to look at the interaction points, right? I mean, they could technically call this ports, but they also use the same interface for other purposes. So they call them which is a port is an interaction point, right? So it's not wrong. And then I can say, okay, I want to show, let's say I want to display all of them, right? Okay, so here's now my two child, whoops, sorry, my 2 child ports. Let's make this one a little bit larger. Okay, something like that, right? And so now I can kind of put one on one side and the other on the other side. So in an IBD, that could be quite useful, right? Because now you can actually show the connectivity between these guys. And we can make this string a little bit easier to work with, something like that, right? So that's essentially what we're talking about. So full ports mean that the full functionality that the connection to it would require is performed by the port itself, by the full port, which means by definition, when you use full port, you have to associate it, you have to type it, right, with an actual block, like in this example. We're doing it with with the bolts in this particular case, or in this case with the mount, right, which itself is a hardware. So when you're dealing with mechanical connectivity, right? So how, like if you guys have some devices that you sell or manufacture that go into the vehicle, maybe some of them need actually a bracket, right, to actually go and be connected into the vehicle. Other ones may fit into something the vehicle already has. So, that could be a physical connection point. You literally slide it into something, or, I mean, I don't know. I haven't seen any of your devices, so I don't know. But it's probably a realistic case that you're going to have like literally mechanical connectivity, and you would use, for that, you always use a full port. Because obviously there's nothing, since we're dealing with like physical connections between, like, say, two pieces of metal, for example, then there's no way of delegating, right? Because a proxy, when you use a proxy port, by definition, it means that the port itself doesn't do anything. So it needs to go inside, right? Inside the block that it's on, and the inside of the block has to take care of the real work. So that's the main difference between the two. So, I mean, for sure, anything mechanical connectivity, useful ports, but there's probably, like I said, there could be cases that you can come up with where you're looking at something that say, this needs to remain a black box. We're not going to expose, we don't want to like show anything of how the internals work. We don't want any other wires or anything to go inside. We're just going to put this thing, right, as a separate, like, attached unit to it, and it will take care of connectivity. Unlikely, right? But it's possible. So this is kind of here the mechanics that we just went to, right? Port size customizable, and then you go to the interaction points and you decide, okay, I want to see, maybe I want to see half of them, you want to see all of them. Right? So proxy port, which is like the other side of the fence, right? So it's going to expose, if you will, expose, or at least it's going to use, it's going to define a touch point between two blocks, where these blocks are basically related, connected to each other, right? And they are connected through proxy ports. But the proxy port, unlike the full ports, the proxy port is just basically a declaration through the interface. It's just a connection point. The port itself is not going to provide any feature. So when you associate a port with an interface block, so it must be typed, right, by an interface block, the port itself is not responsible for doing anything. Like the exercise you just did, right, with the 5, what is two operations and 4 properties, none of that is, none of the properties, none of the functions are actually provided by the port. Right? The port is just an attach point and an interaction point. The whole purpose of it is for you to associate it with an interface, with a contract, right? That then basically provides the contractual obligations, if you will, between these two blocks, between these two components. So it is a pass-through, right? And actions on features may have the same effect on the owning block that the ports. Yeah. So because it's the ports basically is going to turn around, right, and just essentially just delegate, if you will. And in UML, there is actually concept of delegation. SysML, it's just implicit.
So Frank, real quick. So I created the full port, but when I'm trying to drop another port, happening. So yeah, you see, you get the additional ports.
Right. So it's not like you're physically dropping, well, maybe you want to share your screen, but if I try to do this, drop a port on a port, well, I mean, they'll put something there depending on exactly how you drop, but they're not going to be inside, right? So the idea of ports within ports, the only way you're going to get ports within ports is that you have a port, a full port, that is typed, right, by a block, which it has to be, which itself has ports, which could be, well, I guess it could be proxy port. I don't think that would make any sense, but generally, right, they're full ports again. So it's like that's how you get the second level. Does that make sense?
So you said it needs to be typed by the block.
Right. So you have to associate the full port. Like here, I didn't actually do that, right? But if I created a block called, like, a bolt or something like that, mine wasn't the full example, like the one I have in my PowerPoint presentation, right? So, but yeah, the full port, when you create a full port, here I didn't actually do the bolting, right? Let me take this guy back up. But here I did, right? So I created this full port and I said, okay, this port, if we look at the properties, right, of that port is typed by mount, right? Mount is this block here in order to get the secondary level, right? So every full port should point to a block. But if that block, so in this case, this full port, which is what it is, right, this big rectangle here, is still a port. And the port is basically typed by, right, or defined by, right, this particular block, which itself has two full ports. That's how you get ports within ports.
Okay.
Right. Not by physically trying to squeeze one port in another. Right. Does that make sense?
Yes. Kind of.
Kind of. Yeah. Because
Here, let me share my screen and you can maybe help me through this.
Okay. Yeah. Yeah. Sure.
Okay. So I've got this block it says it's the block or the type is block.
Right.
But then when I try to add a port, it won't add one to either the block or the port.
That's interesting. All right, let's see. Well, you do have a full port there. That blue guy is a full port, so you know.
Right. So, but then you had added additional ports onto this, and that's what I was trying to do, but
no, that's what I was saying is no, it won't let you do it, because when we have nested ports, what is meant is that if you just create another, so add a second block now. Okay, and now add a full port to that block.
Nope.
Or you could use a regular port for the sake of, that's fine. But
I'm trying to remember how we got it to be the full port.
Yeah, you just go and change the stereotype. So,
oh, that's right.
Yeah.
There it is.
Yeah. All right. And so now you have the blue guy there, right? The port 1 that you created in the other block. Okay. So now go and type it. So in other words, bring up the property sheet. So you have it on the right, or you could do Control L if you want, right? It's a fast shortcut. But otherwise, you just go into property, right? And now go into your little, whatever your little example model is. I think it's like, yeah, exercise 4. And look for your block 1 there. Yeah, there it is. Okay, so now, right, you have a port that references block 1, which itself has a port, right? And so now if you keep your port 1 selected there, and now go bring up your features window on the right, and go all the way to the end where it says interaction points. Port block 1, why is it? Oh, gosh. Why is that not showing? I'm trying to think. Is it because, let's make sure, well, okay. So that port 1, the blue guy, that is like literally within the block, right? It's not like, why, I don't think the tool would even let you do it any other way. Yeah.
Yeah.
So that is kind of interesting.
Maybe because it didn't name this one or something.
So this one has the port. Okay, let's click on the blue one once again. No, I mean, oh no, it shouldn't matter that they didn't give it a type. That shouldn't matter. I don't think so. And so go back to features now. Maybe it's a refresh issue. Oh, yeah, there it is, port 2.
There it is.
2 seconds ago it wasn't there.
Yeah.
But now it's
okay.
Right. Okay. Yeah. Right. So now you have a port within a port, just like in the example in the one that was on the slide. If you remember, right, it had like 10, right, or eight ports, right? The 8 ports that you were seeing in the camera port was came from the mount, right? It's basically, so you're not inheriting, but you kind of, in a way, well, it's not pure inheritance, right? But you kind of acquire these other ports by having the first port, right? Then which points to something that has the extra ports. And technically, you could have ports within ports within ports, but never directly. It's not like you create them one within the other. It's basically by associating the port, with a block that itself has ports, right? And same thing with proxy ports. Proxy ports can also have references to other proxy ports. It's the same concept, but by pointing to an interface which itself has other proxy ports. So that's the logic.
Okay. Awesome. Thank you for that.
Yep. So so proxy ports, right? So it does not specify a separate element, right? It doesn't do anything, like I said. but it is associated with an interface like the one you created in your exercise, right? And then it should be in the IBD, technically speaking, right? You should then show, because since it's a pass-through, it's like, well, you're passing through to something, right? You have to actually, something in the block has to then really do, right, whatever the interface specifies. So and then nested ports would be proxy ports as well. And I think that's really true with full ports as well. It's like full ports should only have nested full ports, because logically it doesn't make too much sense to do it otherwise. But I could be wrong on that one. So delegates, right, the direction on both sides was matched. Yeah, obviously. So we'll take a look at these directions in a little bit later. So if we look at some examples here, all right, and then I'll have you guys, yeah, go ahead. Oh, I'm sorry. I forgot to take control again. My bad. Thanks. Thanks for pointing that out. So let's see. Yeah, all right. You should see it now. All right. So on the proxy ports, what was I saying? Yeah, so must be typed. I think we talked about that, right? Should be connected to internal parts. So in other words, because you are, since the port itself doesn't do anything, right? You're just a pass-through. It's like a window or door, right? But now you're walking into the building. Something in the building has to then do, right, what the customer wants, so to speak. So if we look at this little example here, this is from you have a couple of example models in your training material here. We're not actually going to look at them, but this is like an air compressor. I'm not saying there's like 100, or actually that's an exercise. So that's one which we're not going to have time to do. But there's two example models. There's a security system. So some of the screenshots you saw come from the security system, and the other one is a water distiller. Right, and again, it's not 100% specified, but it has decent examples of, like, requirements, use cases, and structure, value types, right, specific to the security system, or specific to to a water distiller, for example, right? So this particular example here comes from that water distiller. And so the distiller itself, right, has 4 proxy ports. Right, so as a distiller, essentially, it's going to take in 2 things, right? From an input perspective, right, it's going to take in dirty water, essentially, right, fluid, dirty water, and it's going to take in heat, right, and then it's going to push out, on the output side is going to generate, if you will, a purified water, and then it also has a bunch of sludge, right, that it needs to get rid of. So from that perspective, from a connectivity perspective, right, we have the distiller block, and it has 2 interface blocks, right? One is the actual fluid, water, in this particular example, right? But this is like a generic interface. It just says fluid, and then the other interface is basically the heat, right? So again, from an interface perspective, in some cases, we're going to look at the interface itself looks at it from the incoming side, right? It says to this interface you receive, right? Because it says in, you're going to receive some fluid, or you're going to receive heat source. So if we now look at these 2 proxy ports, right? One is typed by the F port, right? The fluid port. The other one is typed by the heat port. You're going to see that the tool then is pretty smart. This is SysML specification, right? So, but they actually implement it correctly, which is when you have an interface with flow direction on it, and this is what these things are, right? There are properties exactly like the ones you already seen that you built in your exercise, but there's a direction on top of that, right? So you give it an extra meaning. It says this is meant to be coming in. Then this particular, you see the little arrow, right, going in. It's like, well, that's because the tool looks at this interface, sees in, and says, well, okay, right. So when you actually at later point in time in an IBD, right, when we connect this here, we're going to have essentially fluid, right, coming in. We're going to have heat coming in. Now the interesting part is this. Now you look at on the output side, right? We use the exact same interfaces, right? But we have this little tilde, which we, I don't know if we have enough time today to cover that in detail, but so the idea is that, like I said, because if you're using an interface always from one perspective or another, right? So arbitrarily, in this case, I decided that this interface is going to be looking at the side of the incoming, right, from the incoming fluid. I could have made this out. I mean, it would have been, again, 100% arbitrary, right? But I decided to make it in, and then maybe say that in. So that means that on those two ports, when they are typed, right, by these two interfaces, there's nothing else I need to specify because they are conformant to the interface, right? I literally mean incoming, right, water, incoming heat. Versus here on the outgoing side, when the distiller is done with his job, then I need to say, by the way, on the port, not on the interface, right? On the port, I need to say, by the way, your logic is flipped around, right? So in other words, if the interface says in, right, then now you become out. That's why you're seeing here, you see without the tilde. So graphically, you get a tilde to tell you, oh, this is a reversed interface, right? It's I mean, why does UML SysML do that? Well, okay, if they didn't give this ability at the port level to basically flip the logic around, right, of whatever it is, that's the direction. We're talking about direction here. To flip the direction around, then you would need to create not 2 interface blocks, but 4, right? One that basically has in, and the other one almost looks exactly the same, but it would have out, right? So I would create 4, and you could do it that way. It's not wrong, right? And you could have 4 interfaces instead of 2, but they give you the, if you have hundreds of interfaces, then if you could cut it in half, it's not a bad, right? Not a bad solution to just do it that way, to basically say, okay, I'm using the exact same declaration, except that if there is a direction on it, then I'm flipping it around, right? And so in this case, what becomes in goes out, or becomes with directed feature, or becomes provided becomes required, what becomes required becomes provided. So that's the logic. So graphically, I'll show you how to set that. There's like a flag, what you set on the port, on a proxy port specifically. It doesn't apply to full ports at all, but on proxy ports, it's a flag on the port itself that says, okay, flip the logic around. They call that conjugation. Don't ask me why it's called conjugation. That's just how it is in the UML spec. Here's another example, right? The heat exchanger, again, it has cold in. These are just the names, right? And then cold out, again, same thing, right? There's, in and out. Here I'm basically also showing it on the name, right? It's a little bit easier to read that way, but it just is the label, just the text string, right? Cold in, cold out, but hot in, hot out. The heat exchanger essentially, right? Again, using the same interfaces, but I have to, on the output side, right, I have to flip it around. And when you flip it around, then the tool is smart enough to say, oh yeah, well, this is now an outgoing arrow, right? You're going out as opposed to an incoming arrow, right? Because otherwise, without flipping it around, the arrow would point this way, right? But now it's, and so when you have a direction like that, and the tool really helps you make sure that you have your logic straight, right? Because you can kind of see it. Okay, yeah, it comes in here, boom, 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 goes in, right? Same thing here. That makes sense a little bit. This whole concept of conjugation, right?
Makes sense to me.
Yeah, it's just a way to kind of minimize, not have to have duplicate, like mirror image, right? Every single interface otherwise would need a mirror image. So here's another one, right, with internal. So on the IBD side, it's a different example, right, where you have like full mounts on the mount assembly. This is the wired camera, right? So that would be another example of a full mount, right, connected to the mounting plate. So that would be like a kind of hardware connection between these two full ports. And this is like the platform on the mount assembly. And then the mount assembly has connectivity to an electronics assembly. And that here we see an example of a proxy port, right? So it has a composite video interface, which I'm not actually showing the interfaces in this particular example, right? And then gets pushed back out, right, to the composite video interface of the camera itself, right? So this is just again a connection point, but this is a separate, right? Electronics, a separate component, right, within the camera that then has some kind of wire connection, right, to go out of using some kind of interface, right, back on the back of the camera to go out and to basically then be sent out, right, for example, to the monitoring station of something like an ADT system. And here we have the connection of a power, right? You have power with a 3 AC plug interface. And then again, this is like, in this particular case, if you actually saw the the plug interface definition, which I'm not showing you unless I have it here now. It could be something like this, but you will see like in out, right? So you have in, out, but anything that is like, well, power potentially or things like data streams, a lot of times it's in out, right? So if it's an in out, or if you have like, one thing going in and one thing going out, you could have two properties on here, right? One that says in, I think I showed you some examples already of that. One that says in and the other one that says out. Then the tool is smart enough to say, oh, it's a combo, right? So I need to, rather than just showing you, an arrow one way or the other, I need to show you like this, right? It's like, it's not less or greater sign, right? It basically means it's bidirectional. Right? So you have bidirectional connection in terms of the AC plug interface to the power supply, right, which then provides power to all these different connections, which really should also technically be through ports. But and then there's an Ethernet card here that this receives power, and it's going to provide Ethernet connection, again on a female connection to the outside to an RJ45 interface. So little examples, right? So mount assembly are not encapsulated. Provide that parts to be, so it's basically also showing that you can't connect things directly, right? If you don't look at it as a black box, you can say, well, this is just a fold, it's like a mechanical thing. So but the same thing on the electronics assembly, right? We're connecting directly from within the composite converter, right, to like to the attach point on the camera itself, right? So they're not the parts to be connected, but maybe this is something that you actually build, so you have your own connectivity, right? You kind of decide that you can connect things directly to the outside world that way. But if you have things like Ethernet cards with things like commercial or off the shelf, not necessarily commercial, but off the shelf components like power supplies, Ethernet cards, I mean, generally you're not going to go inside, right, to kind of look and connect to something inside. To you is like a black box, right? So they are encapsulated, and then you just connect them to the outside directly. So in other words, right, unlike here when we kind of jump inside the fence and we say, oh yeah, that's fine, right? Here we decided not to do that, but these are like black boxes, right, to use, and so therefore you just go connection to connection without, you're not interested, right, and what the internals or how the Ethernet card works with the power supply. Now, by the way, on when you have interfaces like an RJ45, which there could be a direction on it, right? But you're not forced when you create interfaces. You can, I mean, like in your exercise, remember that we didn't do flow properties, right? So, like, if what we're going to use, the example that you built, the interface that you built for that we're going to attach to ports in tomorrow in our next session, then you're not going to see little arrows, right? The little arrows in SysML only come when you have flow properties. That's the only thing that, and the tool basically honors that. They'll look at flow properties to determine if they need to put in a little arrow there one way or the other, or bidirectional. When you have, so I don't have this interface here in the diagram. Obviously, it is not built within for the flow property, right? Because otherwise we would see an arrow in here. Right? And we'd see a little arrow. Same thing on the composite video interface, right? It's just, it doesn't have the arrows. That's why, I mean, even though they're proxy ports, doesn't mean that you're always going to see a little arrow. It depends on the interface that you have, right? And whether you put flow properties on it. But if you do put flow properties, and you could have, like I said, multiple flow properties, you can have a combination of flow properties and other properties. But in any case, if you have a flow property on it, then the tool will basically look and say, yeah, okay, I need to give you a sense of direction, right, on that. And so this is kind of what we just looked at, right? I showed you already some examples, right? Two blocks interact, right? You want to be able to use one interface as opposed to mirroring, right? Creating two interfaces. So in that case, so what it will reverse is directed feature, right? Where we know there's required provided. So required compose provided, right? And vice versa. And then for flow properties, right? If it's in, it becomes out. If it's already in out, there's no change, obviously, right? And then full ports, of course, it doesn't apply to that. So if we looked at our example here, I only have full ports. So I actually have this proxy port here. So if I look at the proxy port, and we're going to basically use this property here, conjugated, right? So if I mark this, right, it will say conjugated here. What happens also if I if I make it visible, right, then it should actually show me, probably because I didn't type it, right? So let's actually make this a little bit better. Let's actually create some interface block, right? And then here's my port. So we'll type it with this interface for now. So at least this has something to show. Okay, so once you actually type it, which you should do, right? You should always associate with an interface. Now they have something to show as the tilde, because they won't show you a tilde without a name next to it. So graphically, if a port has been basically, if the logic has been flipped around, but the logic of the interface, the direction of the interface has been flipped around, and you show it graphically, you'll see it with a tilde. When you show it non-graphically, just hitting the delete key here, they'll show you like, conjugated, right? Because it has the conjugated property on it, which you're going to set again in the property window. Okay, so I think they have conjugation. No, okay, so there's a bug when the tool used to have conjugation in two tabs, and they didn't result in the same thing. Now they fixed that bug, so conjugated only shows up on the element tab, which is fine, right? Then you check mark it. And that's about what we're going to cover today. Then tomorrow we'll talk a little bit more about that, but I'll have you guys then use the interface that you built in the previous exercise, and then we'll add some ports, and we'll I'll let you guys play with that. So any questions before we finish for today?
I think I will have to digest this last part prior to the questions, but I wanted to say before everyone goes, reach Justin or anyone else. I made a Dropbox account on my JB Pico email, and it's run out of space with the video from yesterday. So if anyone has more space, would you mind copying it over to the shared drive so that, those of us with only 2 gigs, if there are certain ones aside from me, can get access to it, because mine is no longer synchronizing.
Yeah, so mine ran into the same issue, but I was able to kind of close out and go back in. But yes, I'm going to be downloading it tonight, and I'll upload it to Teams.
Oh, okay.
Oh, yeah.
Appreciate it.
Yeah, if you put it on Teams, yeah, that's probably the best solution. And you may want to, so once you've downloaded it, because that's, with a slow network connection, that's going to be most of your time, right? I'm just going
to set it and forget it tonight.
Yeah,
yeah,
exactly. And then, to turn that into a zip file took like maybe 2 minutes on my system. So before you pass it on and put it on SharePoint and pass it into the rest of that, to Alejandro and the rest of the team, I would just, at least save another 1 gig.
Yeah, for sure.
Yeah.
Yeah. Okay. Thank you. Appreciate it, guys.
Yep. Thanks, Frank. Appreciate your time.
Yeah, no worries. Talk to you guys tomorrow.
Talk to you tomorrow.
Yep. See you tomorrow. Thanks, Frank.
Yep. You're welcome.